branch of things used to be called neurocomputing, and I think there's an interesting overlap here in something called natural computing. This is one of the things that we study here in the sandbox. And there's a sort of a bunch of things that come together, and the idea is that we need to look at nature to figure out how computation works. What's happening in the blade of grass, what's happening with seagulls as they search the beach for food. Who's ever made the mistake of giving a seagull a french fry? They all come out of nowhere. They have the entire ocean to look for food. How do they know to show up at your picnic? Same with ants in Florida and so on. And so this kind of computing that nature does all the time is things that we need inspiration from. A few decades ago, people said, well, we probably don't need that. But it was so successful to look at the brain and to look at these neural networks that now the idea is that we need to go and look at, well, how do friend groups form with social computing? How does physics actually compute? If we go like this, that's computing the sound that it just made. It's not a very interesting computation, but we can think of it as there was an input and there was an output in terms of the sound. Developmental computing. How do we actually form the structures that we have? How do you take an acorn and get an oak tree out of it? How do you take a human cell and get a full physiology? On the other scale, with evolution, and one that I think is particularly interesting is immunocomputing, looking at our immune system. Your body remembers that you've had chickenpox. And in there, if you ever encounter that again, your body remembers the solution and it can pull that out of its memory and use that to help fix it. Kind of like the brain, but has very different properties. This idea of multi-party computation is an idea of how do you split up a problem into a bunch of little pieces such that you can have people participate on the problem but not actually know what they're working on. This was actually done in practice, again during World War II, when people were working on the atomic bomb project, largely at Los Alamos. They were able to split that problem up into so many little pieces that most of the people helping on what's now called the Manhattan Project not know what they were helping with. They split the problem into little pieces, and they would say, all right, here's a dial, and here's a little wheel, and when it goes this way, turn it that way, when it goes that way, turn it this way. And they'd say, okay, glad to be helping. They had no idea that they were helping diffuse uranium. And so the idea is you can take a big, complicated problem and split it up into little pieces, such that the actual problem itself stays a secret, but you can still get the answer.